Very good morning. I am Dr. K. Selvan, working as an assistant professor in the Department of Computer Applications, JJ College of Arts and Science, Pudukottai, Tamil Nadu. In this session, I am going to explain very clearly designing a software. Designing a software. So we know very well that software is a collection of programs, related programs. So banking software means there are so much of manual activities, cashier, teller, loan, budget. Okay, these are all various manual activities going inside a bank. So a separate software modules is developed. Okay, so these modules are more related. How it is related? These are more related to bank. Okay, so the related software modules are integrated. Okay, such a integrated software modules, collection of modules are called a software. Okay, here how we are going to design a software. So in developing a software there are so much of activities. First one, collection of requirements. Second one, analysis. And third one, design. Fourth one, implementation, that is coding. Next one, testing. Finally, maintenance. Okay, so these are all the various activities involved in developing a software. So an important activity of developing a software is software design. Okay, so here we are going to discuss elaborately software design. Software design, there is a definition. Software design is an iterative process. Software design is an iterative process because an entire software cannot be designed within a minute or within an hour or within a day. Okay, so the same design process going to be an iterative one for each requirements. For a single requirement, it have to be molded again and again. Okay, for the entire collection of requirements, the same design process going to be iterative till it's come to terminate. Once that design activity completed. Okay, so that the definition of software design deals, software design is an iterative process through which requirements are translated into a blueprint. Okay, I told already the initial activity of software development is requirements gathering. Okay, without requirements any product may be developed. Okay, so for producing any engineering products, requirements must be defined. Okay, so the defined requirements are going to be converted into a blueprint. So in software, the requirements are going to be converted by design notations. There are various design notation. Using these design notations, the collected defined requirements are going to be converted into models. Okay, then only it will be converted to coding. Okay, a blueprint is a reproduction of a technical drawing. Yes. Okay, a blueprint means collection of design models. There are so much of models: data dictionary, er diagram, use case diagrams, logical templates, data flow diagram, uh, algorithms. Here are very known models. Okay, using these models, one requirement can be converted, can be translated. Okay, one requirement can be translated into these various models: data dictionary, data flow diagram, data transition diagram, logical procedures, templates, ER diagram, use case diagram. So then only a full-fledged software may be developed. Okay. Initially, the blueprint depicts a holistic view of the software. Okay. Very initially, the software is viewed as a collection of requirements, then collection of data, then collection of design models, then software module, various modules. Then in testing, these modules are going to be integrated. Finally, a collective, a defined, well-defined software created, and it will going to be submitted to client. Process of design engineering. During the design process, the software specifications are transformed into design models. I told already. Models describe the details of the data structures. Okay. System architecture, interface, and components. Model describe the details of data structures, system architecture, interface, and components. Each design product is reviewed for quality before moving to the next phase of software development. Okay, once a requirement translated into a right models, then only we can move on to the next phase, that is coding. At the end of the design process, a design model and a specification document is produced. Okay, once the models are developed, finally the design activity going to be terminated. This document is composed of the design models that describe the data, architecture, interfaces, and components. Design specification models. Okay, actually the collection of requirements. Okay, these are all going to be converted into data design, architectural design, design interface design. Design interface means between two modules data going to be moved. Okay, so this interface must be defined very clearly. Then data design, created by transforming the analysis information model into a data structures required to implement the software. So in a software we can see four activities: getting input, validating input, processing the data, finally outputting the information. Okay, so here the data plays a very important role. So we have to identify the data. So designing such a data is called a data design. Next, part of the data design may occur in conjunction with the design of the software architecture. So we seen the four activities in design. Okay, so if we do one type of design, partially another design completed. Next, more detailed data design occurs as each software component is designed. So just be spelled. So data design done by data dictionary and ER diagram. For designing data dictionary and ERD. ERD means entity relationship diagram, used very much. Then architectural design. So architectural design defines the relationship among the major structural elements of the software. there are so much of major structural elements. Okay, so here in architectural design, we are going to exhibit the relationship among the major elements of the software. Okay, then interface design. So this interface design describes how the software elements communicate with other. Okay, so much of the necessary information required is provided by the data flow diagram and control flow. So data flow diagram going to depicts the flow of execution. Okay, which activity, which statement going to be executed first, next and last. Then procedural component design. There are some design fundamental concepts: abstraction, architecture, patterns, modularity, functional independence, refinement, and refactoring. Okay, these are all some fundamental design concepts. So, abstraction, data abstraction, procedural abstraction, and control abstraction. Without the concept of abstraction, it is impossible to design. Architecture, patterns, modularity, information, functional independence, refinement, refactoring. So, in the next session, we will discuss elaborately the fundamental concepts of design, software design. Thank you.